Hello guys, how's it going? This is Amell again with another video for you about coding interview questions. And this time we're going to talk about two-sum number 2. In this case, the array or the input array is already sorted, so we have to take advantage of this property. Last time I showed you a way to solve the problem, but the array was not sorted, but this time we need to use that property because in that way we can save space. Last time we were using a hash map, a hash table data structure, and so we were using big O of n space and it took big O of n time. But this time we're going to use the two-pointer technique. So we're going to take big O of n time, but the space is going to be constant. So without further ado, I'm going to explain to you the way we're going to solve it. So they give us an array. The array is sorted in ascending order, and we have two numbers. And we need to find two numbers that they add up to a specific target number. So we need to find those two numbers and return the indices of those two numbers. And the indices are not zero based. They have to be one based. We're going to do this by having two pointers, left and right. Left is going to point to the beginning of the array, and right is going to point to the end of the array. And every iteration, we're going to calculate the sum of the left and right numbers, and if it is equal to the target, then we found those two indices and we can return the result. If it is less than the target, then we want to make it bigger. We want to make the sum bigger, so we have to increment left. Otherwise, if it is greater than the target, then we have to make the right small. We have to make the sum smaller, so we decrement right. So this is, we're gonna start coding it here. First, I need my result array of size 2. I'm gonna initialize the first element to be -1 and the second element to be -1 as well. And I'm gonna do the null validation. So in an interview and also in real coding, it's good to validate the input. Like if you have a pointer or a reference, make sure that it is not equal to null. Or if the array is empty, then there's no solution and we can return the result. And now we need the pointer left. It's gonna point to the beginning of the array. Right is going to point to the end of the array, so numbers.length -1, and we're going to have a while loop while left is less than the right, because we want to, if the left equals the right, then we only have one element, so there's no possible solution. So that's the condition when the loop is going to break out. So we have to maintain this condition. So integer sum gets the value of numbers sub left plus numbers sub right, and now we check if the sum is equal to the target, then we found those two indices and we can return the result. So we can say result of 0 gets a value of left plus 1. So remember, this is 1 based, so I have to add 1 to the left index and also to the right index. And results of 1 gets a value of right plus 1. Then we return result. Otherwise, if the sum is less than the target that we're looking for, we want to make it bigger. And how can we make the sum bigger? We have to increment left, because other numbers to the right of left are bigger, so that's going to make the sum bigger. So we can increment left. Otherwise, if the sum is bigger than what we're looking for, we want to make the sum smaller. How can we make it smaller? By decrementing right, because other numbers to the left of right are smaller. Alright, finally we return result. So let's check if it's working. As you can see, it's working. Let me submit the solution. Success. So as you can see, this solution is fast, and the time that it takes is big O of n, and the space is constant space. Because the array is sorted, we do it this way using the two pointers approach, the left and right. And this is the continuation to the two-sum problem. This is when the array is sorted. I hope that you enjoyed this video. Thank you for your support. Please don't forget to subscribe and please like the video. Thank you and see you next time.